Hi, this presentation for the course Introduction to Optics. It's about what's light, a wave or a particle. Starting with introduction, some questions about light have separated scientists with different conclusions for years. Example of these equations is what's the true nature of light? Is it a wave or a stream of extremely small particles? Around 1700, Newton concluded that light was a group of particles, corpuscular theory. Around the same time, there were other scientists who thought that light might instead be a wave theory. The corpuscular theory, however, cannot explain wave light like light phenomena such as diffraction and interference. The wave theory cannot clarify why photons fly out of metal that is exposed to light. The phenomenon is called the photoelectric effect, which was discovered at the end of the 19th century. So, light is a particle for Sir Isaac Newton. The English physicist Sir Isaac Newton, known for the law of the universal gravity, he realized that light has frequency-like properties when he used a prism to separate sunlight into component colors. Still, he believed that light was a particle because the periphery of the shadows it created were extremely sharp and clear. On the other hand, Grimaldi and Huygens thought light is a wave. The wave theory, which maintains that light is a wave, was proposed around the same time as the Newton's theory. In 1665, Italian physicist Francesco Maria Grimaldi discovered the phenomenon of light diffraction and pointed out that it resembles the behavior of waves. In 1678, Dutch physicist Christian Huygens established the wave theory of light and announced the Huygens principle. So you can see Huygens principle here. It's indecent plane wave and outcome is wave past small opening. So for Fresnel Young, light is a uniquely a wave. French physicist Austin Young Fresnel claimed that waves have an extremely short wavelength and mathematically proved light interference. He also hypothesized that space is filled with a medium known as ether because waves need something that can transmit them. In 1817, English physicist Thomas Young calculated light's wavelength from an interference pattern, thereby not only figuring out that the wavelength is 1 micro or less, but also on the truth that light is a transverse wave. At that point, the particle theory of light fell out of favor and was replaced by the wave theory. So you can see Young's double slit method is similar to Huygens. So for Maxwell, light is a wave, an electromagnetic wave. The brilliant Scottish physicist James Clerk Maxwell in 1864, he predicted the extent of electromagnetic waves. Out of his prediction came the concept of light being a wave, or more specifically, a type of electromagnetic wave. He presented Maxwell equations for electromagnetic theory that shows magnetic fields and electric fields are inseparably linked. This led to the introduction of the concept of electromagnetic waves other than visible light into light research. Here is the Maxwell equations. Light is also a particle. Albert Einstein thought. Einstein believed light is a particle, photon, and the flow of photons is a wave. The dual nature of light as both a particle and a wave has been proved. Its essential theory was further evolved from electromagnetics into quantum mechanics. The main point of Einstein's light quantum theory is that light's energy is related to its uh, oscillation frequency. Photons have energy equal to Planck's constant times oscillation frequency, and this photon energy is the height of the oscillation frequency, while the intensity of light is the quantity of photons. The various properties of light, which is a type of electromagnetic wave, are due to the behavior of extremely small particles called photons. And so for the conclusion, light is a complex valued probability distribution that has quantized properties such as energy. Like a wave, a photon experience diffraction, bending around corners, interference, fringed patterns, refraction, bending when entering a material, reflection, dispersion, wave shape spreading, coherence, lining up of phases, and has a frequency. But for like a particle, a photon contains a fixed energy, a fixed momentum, a fixed spin, and can be measured to have a single fixed location in space. The wave-like and particle-like features of a photon trade-off according to the Heisenberg uncertainty principle. The more you force a photon to act like a particle, for instance, by confining it in a small box, thereby lowering the uncertainty its position, the less it acts like a wave. So there was presentation of what's light. Is it a particle or a wave? Thanks for watching.